Hello and welcome to the August update from the TauNet team. You're here with me, Fola. It's a development team update, so I'll be passing it over to Karim for his update and overview this month.
Thank you, Fola, and welcome everyone to the August update for the Tau development team. Let me start with Andrei. He's continued his work on the architecture and implementation of the Tau testnet. He actually created a pseudocode for the entire Tau blockchain with all of its essential components. He also built an implementation of a blockchain using the Polkadot SDK, which will allow us to test any single Tau subsystem in a fully functioning blockchain environment. Aside from all these developments, he also continued to enhance and maintain our key services, including Telegram bots, websites, and application servers. David continued his work on the solver. He made some marked improvements and fixes to the solver itself and gave us a demo last week. On the testnet side, he continued participating in the testnet discussions and went into lots of implementation details with Andrei. On performance of Tau language, he added the new target to build and run performance tests needed to assess the performance of the Tau parser and normalizer. He added tests to the benchmark to benchmark the performance of the Tau implementation in several test cases. He extended some measures in the parsers, which include counters for different internal function calls. He also added measures to the target with respect to the dev info, which is used in benchmarking performance. He also added many helper functions to simplify the use of the performance profiling features. He also moved all the simplification rules and definition rules and several callbacks to the creation of nodes to speed up execution by reducing the number of calls given the benchmarks he ran. And then he rewrote the API to apply as much as possible rules during the creation of nodes instead of the traversal. And then he added caches to apply methods to reduce the number of traversals as well. On other tasks, he cleaned up some of the grammar features and avoid quantifier elimination in trivial cases. He also fixed a bug in NSO operator and cleaned up the code that was unused for builders and methods. Lucca reviewed and optimized David's implementation of the normalization process. In addition, he implemented the reduction rules for Tau formulas for non-resolved functions and recurrence relations. He also implemented the feature allowing non-disjoint DNF clauses in the output of Boolean function normalization. He also implemented a more advanced quantifier elimination algorithm with the help of Ohad. Added a feature to the splitter algorithm whereby it can take into account constants appearing in Tau formulas and various other minor improvements and bug fixes. Umar was actually on vacation for the most part of August. However, when he came back last week, we did the review of his super optimized implementation of binary trees and DAGs. And Ohad's assessment of it was that Umar actually managed to improve on Ohad's own implementation of binary decision diagram library, which actually is a huge praise coming from Ohad. Last but not least, Tomáš started out the month with doing some house cleaning and refactoring on the code, as he usually likes to do. Then he updated all the calls to the parser with relevant grammar symbols. And then with respect to recurrence relations, he added support for calculations of all fixed points. He merged all the type inference code into the main branch. He fixed a bug in the normalization of Boolean functions, which appeared after the merge. And then he added validity checks that main cannot contain relative offsets. So relative offsets can only be used in rules. And then he fixed another bug whereby type inference messages were printed multiple times. On the Tau syntax side, Tomáš removed the $sign from the start and offset of each argument variables. And on request from Ohad, he allowed grouping of nested quantifiers, and then he added support in the grammar for temporal flags and added printers for them. He also allowed now the variable use of the letters I and O, which were previously reserved for input and output. He fixed the priority of variable names versus Boolean function conjunction. He fixed priority of formulas versus Boolean functions in the REPL. He also removed the now obsolete explicit typing of formulas and Boolean functions in the REPL. And he also fixed and updated the syntax of constant types and in type inference, which is actually still a work in progress. That's it for the Tau development team update. Hope to see you next month. Thanks, Fola. Back to you.
All right, fantastic. Thank you very much, Karim. And I'll pass it over to David for his update this month.
Thank you, Fola. Hi, everyone. This month, I've been working on several tasks. Regarding the solver, I have made several fixes and improvements in the code and continue testing it. Regarding testnet, as usual, I have participated in the discussion and also start working certain specification details. However, my main focus this month has been the performance of the Tau language. In order to compare the improvements in the performance, I have added a new target to the build just to run the performance test. In order to do so, I needed to refactor the current builds of Tau and the parser so they work together properly. And the test that we run in that new target store the results in files in order to easy the comparison between different commits. Regarding the measures that we could consider, previously we only have timers. Right now I have included also counters. But once we have all the performance measures in place, we were able to improve the performance of the Tau language by means of changing the rewrite API to apply one rule over all possible nodes in one traversal, moving all simplification rule, definition rules, and several callbacks to the creation of the nodes. So we speed up the execution by reducing the number of traversals and also applying several cache in the apply methods in order to also reduce the number of traversals. Apart from that, I've been cleaning up the grammar, removing some parts that weren't considered anymore, in particular, for example, Boolean quantifiers that were used previously in an old version of the satisfiability algorithm. I have also made changes in order to avoid trivial cases when dealing with the elimination of existential quantifiers. I have made several fixes in the NSO operators introduced last month, and also I have cleaned up the code mostly due to the refactors of the performance, for example, builders, methods, and several tests. And that's all for my month. Thank you very much for listening.
Fantastic. Thank you very much, David. I'll pass it over to Lucca for his update this month.
Thank you, Fola. So this month I implemented an additional feature for the splitter algorithm that takes constants appearing in Tau formulas into account so that we can replace a bad splitter by a constant instead, if applicable. Then I reviewed and optimized the overall Tau formula normalization process, which include a number of bug fixes and reorderings of the normalizations we apply in order to achieve a more optimal flow. Then I also implemented additional reduction rules for Tau formulas and non-resolved function and recurrence relation symbols, such that those now also enjoy the reductions that Boolean functions were a subject to before already. And speaking of Boolean function normalization, I added a feature that allows for non-disjoint DNF clauses to be outputted by this normalization process, which reduces the number of literals in each clause in the optimal case. Then I went on and implemented a more advanced quantifier elimination algorithm, or more specifically, I advanced the version that we already had by pushing quantifiers deeper inside, and by reducing the number of tree traversals we need in order to accomplish all of the eliminations. Alongside, I implemented 2 identities we know to be true for our quantification, and yeah, this resulted in a speed up of this elimination algorithm in general. And yeah, that's basically it for this month. And now I will present a short demo of the tau formula reductions and of the non-disjoint DNF clauses outputted by the Boolean function normalization.
All right, fantastic, Lucca. Over to you, Andrei.
Hello to our dedicated TAO community. This past month has been another productive period in our journey to build a TAO testnet, and I've been diligently working on the architecture and implementation details. A significant part of my work involved creating pseudocode for the TAO testnet, and this month I was working on the core pseudocode for the TAO blockchain that involved processing transactions, implementing a new rule, and building the blocks. And this development is vital because it lays down the groundwork foundation for our blockchain, how our blockchain will operate, ensuring that it's capable and robust enough to handle real-world demands. Moreover, I've made a practical step forward by successfully finally building a Polkadot custom blockchain. Now we have a live blockchain environment, and it's not just about testing. It lays a solid foundation for us where we can test and implement and run our concepts within a live blockchain environment. This is really great, and we're all eager to see how it will work, and we of course expect the TAO language release to implement all of this. Aside from these technical advancements, I kept on improving performance and security of our various services. That includes Telegram bots, websites, our servers, platforms. This work might seem routine, but it's essential to keep us and your community interact with stable and live environment. So I want to thank you for your continuous support and enthusiasm. Your feedback helps us keep moving forward, and your interests help us to push new boundaries and innovate further. Stay safe, stay connected, and see you next month.
All right, amazing as always, Andrei. And now I'll pass it over to Tomáš. Over to you.
Thank you, Fola. Hello, everyone. In August, I've been working on recurrence relations, improving calculation of a fixed point and type inference. And I've also worked on syntax changes and fixes. Regarding syntax, I fixed an issue with parsing constants and their source. I've added the required pairing of curly brackets, and it allows the constants to be nested and not matched together. I also added the grammar for temporal flags and their printing. Now we also do not have to write the $sign at the beginning of offset and argument variables in recurrence relations. We now allow variable names to be letters I and O. They should not conflict with input and output variables. And I've also fixed priority issues with variable versus Boolean function conjunction. And this priority fix allows us to use variable names like x0, z1 which were confused with X and 0 and Z and 1. I've also fixed some other priority issues in the REPL, and I've added support for grouping of nested quantifiers. I can show you. So you can now write like all X, Y, Z. You can write now formulas like this instead of just writing all X, all Y, all Z. Which is equivalent. I've also removed some explicit typing of formulas and Boolean functions, and it became obsoleted with the type inference into mine. I've added support for calculation of all fixed point calls in main. For example, we have a reconciliation. You can see that we don't need to write like dollar signs here, and we don't need to write dollar signs here. It's much simpler now. So this is a recurrence relation, and now we can call a fixed point, which worked. But when you want to calculate more fixed points in this one command, so for example, I can have another recurrence relation. And this one, we can, for example, use this n minus 1. So now we have the recurrence relations G, and we can calculate as well fixed point of this recurrence relation. But now, until recently, it was not possible to use the call for a fixed point in an expression. You now can use this, and it would work. I've also added type inference into, and fixed the type inference into mine formula, because when you write just this, and from this it's not clear if it's a formula or if it's a Boolean function. We can infer it from the definitions we entered before. So I've fixed this to made this to work. There was also an issue with type inference error messages. They were printed multiple times, and I've removed these duplicities. And there's also a check for relative offsets. You cannot have, like, for example, G and X, because n is a relative offset. It makes sense only when you have when you use this, because it's relative to left to right side. So you cannot use you can use offsets here, but not in the mine. And then I've updated also all our parse calls to start parsing from the grammar symbol, which is relevant to what we are parsing. So that's all from me.
And last but not least, over to Ohad.
Yes, I continued working on the network specification extension of the Tau language together with Pavel Paris, and also on additional KRR aspects, to develop additional KRR aspects of the Tau language together with Enrico Franconi. And also I was thinking about to extend the Tau language from what it is now to also be able to specify in a logical way to specify a user interface like HTML user interface. And I was lucky enough to find a solution that that is theoretically very easy. So we can say that the theory behind the UI specification is basically finished very quickly, very easily, and from here it will be engineering effort. Yeah, and that's the main stuff.
All right, amazing. As always, thank you to all of you guys for tuning in. And remember that we have a competition going on right now for 200 Agoras for liking and subscribing all of our socials. That's on X. That is Tau Logic AI on X. That is Taunet Agoras. That's Taunet AGRS. That's a subreddit. And obviously you guys are mostly going to be on Telegram, so make sure you spread out from Telegram. The goal is now to start taking TauNet to the masses. This is one of the reasons we wanted you to participate in the previous competition, which was to tell us what TauNet was. We wanted as many people to understand what TauNet was, and now we want people to tell us why they think TauNet is so great. So for a chance to win 200 Agoras, and there will be multiple selected winners, tweet us and also like all of our socials and be in with a chance. So please do that. We would love that. And it's also a win-win for us because we like to see who really loves the project. And at the same time, we also get back to you guys. So yeah, that's it. We'll see you on the next update. Thank you. Cheers. Bye.